So we take a look at number one. Again, variables and numbers are on one side, zeros on the other. So we can start to factor. That's our first step. How do we factor A? There's only two terms. Take out GCF, and our GCF is greatest, that is X. We're going to take on an X. When we do that, what are our leftovers? X plus 2. And I'm just going to say equals 0 because we're solving by factoring. We can't do anything with what's inside our parentheses, so your next step is to take each piece and set it equal to 0 and solve. It's really nice here because you don't have to solve anything. X is already by itself, so X just equals 0. What does X equal in that second equation? -2. Subtract 2 on both sides, you get X is equal to -2. So we set it to 0, then we factor. Our next step then is to graph. And it doesn't need to be this perfectly neat graph. All we need to do is plot the 0, so we plot 0 and -2. And then decide, is our graph opening up or down? How do we know it's opening up? Yeah, there's no negative, there's a positive on the outside. Right, so we know it's opening up, so just connect with a curve. Doesn't need to be perfectly how the graph is. Yes? The dots don't have to be. Not when you graph it. Oh, nope, those are just the zeros. Good question. That only matters on the number line. When you're actually graphing it here, keep it. Keep them as normal points. So then you're gonna look and see. Are we looking if our equation is bigger than 0? Are we looking above or below the x-axis? Above. When it's greater than, we're always looking above. So we're looking at this part of the graph. Because essentially what this is asking us is what x values can we plug in to give us a number that's bigger than 0? Well, if a number's bigger than 0, what do we know about it? Is it positive or negative? Positive. So all our numbers bigger than 0 are going to be above the x-axis. All our y values are positive. Right? So if we look at that part of the graph, is it connected or separated? It's separated. So what do we know that our inequalities are also going to be separated? So we know we're going to have one inequality. Make sure it matches, so there's no line underneath there, so that one's not going to have a line underneath. Or, and we're going to have one that x is bigger than a number. And then all you have to do is look at your roots. What's this root right here? -2. The little root goes first. And then what's the root, the next root? 0. Because if you notice how this arrow is going to slowly get wider and wider and wider, and it's reaching to all the numbers that are smaller than -2. And this arrow is going to slowly get wider and wider and wider, and it's going to hit every number that's bigger than 0. And then just separate it with a little. Now we put these on the number line. What kind of dots are we putting on our number line? Open or closed? Open. Why is it open? No line underneath. So -2 and 0. And you notice how our inequality separated and our graph was separated? What about our number line? It's going to be separated, so we're going to go in opposite directions. Because x is less than -2, so we point to all the ones less than -2. X is greater than 0, we point to all the ones bigger than 0. So now we're going to write this in interval notation. So it's pointing to all the way to the -infinity. And then follow the graph and end where? -2. So that first section will be -infinity to -2. What are we going to put around both? Good. Always put a parenthesis around infinity. No line underneath an open dot, so we have to put a parenthesis around the number. There's a gap, so we put that U. Kind of stands for or. And then where do we start open circle, parentheses around the 0, always around infinity. There we go. So that's essentially what we're doing. You make sure it's set to 0, factor, get your roots, plot your roots, graph, and then look above or below depending on your inequality. Write it as in set notation, graph it on the number line, write it in interval notation. So we look at B, it's the same exact graph. So all we're doing, we're graphing the same thing. We're graphing with the roots 0 and -2. That's not going to change. So then replot it. Connect. This time it's a little different. Because where are we looking? Above or below the x-axis in this one? Below, because it's less than. So we're going to say, hey, which x values can I plug in that will give me a negative number? And that is below. So this chunk of your graph right here. Okay. Well, is that part of the graph connected or separated? Yeah, you're connecting those 2 points. So our inequality is also going to be connected. So it's going to look something like this. Again, you want whatever inequality you're using in the equation or the inequality symbols that you're using when you write in set notation. So there's no line underneath in the one in our equation, so there's not going to be a line underneath with our set notation. And then what's the smallest root? That's going to go first. What's the bigger root? 0. So that's saying any x value from -2 to 0, when you plug it in, you're going to get a negative y value. As y value is less than 0. This is essentially what we're asking for. So we graph this on the number line. What kind of dots are you putting at -2 and 0? Okay, good. No line underneath. And now are we going to connect those or separate them? Connect. And then when we write it in interval notation, we start at -2, comma, we end at 0, and what are we putting around both? Parentheses, because they're open dots. So you can see when your graph is separated with the arrows, they're going in opposite directions, your inequality is going to be separated, and your number line is going to be separated. When it's connected, like in B, your inequality will be connected, and your number line will be connected. They all kind of look in this. Questions over that? No. Okay. Same kind of thing for the next one. Okay. Already set to 0, so we're going to go ahead and factor. There's 3 terms, so how do we have to factor? Split the middle. So we have a 1 out in front. Multiply the first and last. 1 times -24 is... So what are all the factors of -24? 1 and 24. What else? 2 and 12. What else? 3 and 8. And then one more. We hit 4 and 6. Which of those will combine to give us our middle number? 2. Right? 4 and 6. How do they have to combine those to get a positive 2? -4 plus 6. So that's going to be our new middle. So we're going to rewrite it as x squared minus 4x plus 6x minus 24. We're going to go ahead and group them together. Once we get down to 4 terms, we can factor by grouping. What's our GCF between the first 2? X. When we take out an x, we're going to write our leftovers, where our leftovers going to be. Going down the plus sign. Between 6x and 24, what can we take out? And what are our leftovers going to be? Okay. And then write them together. What's going to go in the first parenthesis? 6. What's going to go in the other one? again, they're interchangeable. You could do an x minus 4 in the first one, x plus 6. So when we solve, because we are solving, when we get x ends up equaling what? Good. Because again, you have to set these equal to 0 and solve. So when you solve here, you get negative 6. And when you solve here, you're going to get positive 1. So there are our roots. We'll go ahead and plot them. Negative 6, positive 4. Why is this graph opening up? Oh yeah, we know it's going to open up. You have to pay attention to that. Super important. So are we looking above our x-axis or below our x-axis? Yeah, why are we looking below? Because it is less than. Less than, so we go to look below. So we're looking at this chunk of our graph. Is this graph connected or separate? Connected, so we know an inequality. Inequality is also going to be connected. What kind of inequalities are we using? Do we need a line underneath? Yeah, because there's a line underneath in our equation. We're going to match. What's going to go first? Negative 6. What's going to go second? We start at negative 6 and we end up at 4. And that is all below. We get a negative 1. So we graph these on the number line. What kind of dots are we putting at negative 6 and 4? Closed. Good. Because they are closed dots. There's lines underneath. And then are we connecting these dots or arrows in opposite directions? Connecting. Our inequalities connected. So the number line's going to be connected. How do we write this in interval notation? Where are we starting at? Perfect. Negative 6, 4. Very good, Stan. And we put brackets because they are closed dots. For D, it's nice. It's the same exact quadratic, so we don't need to factor it again. It's going to be the same answer. So go ahead, regraph that one. Negative 6 and 4. And this is a rough sketch. This gives us a good visual. So this time we're looking above or below? Above. So we're looking above. Greater than 0. Right? So is that part of the graph, is it separated or connected? Separated. So what do we know about our inequalities? They're going to be separate. What value are we putting here? What value are we putting in the next one? 4, because here's negative 6. It's eventually going to get wider and wider until all the values less than negative 6. Here is 4, and it's going to get wider and wider and go to all the values that are bigger than 4. So what kind of dots are we putting on our number line? Open, there's a line underneath. And then are we going to connect those dots or arrows in opposite directions? Because there are inequalities are separate. Part of that graph is separate. So our number line will be separate. And since x is less than negative 6, because the goal is less than negative 6, x is bigger than 4, so the point to all the ones bigger than 4. So when we write this in interval notation, where are we starting at? Negative infinity. Follow it, where do we end? 6. And what do we have to put around both? Parentheses. Always around infinity. Open dots. That's why there's one around negative 6. And then open dots, we put a parenthesis. We start back up at 4. And we end at infinity. Questions on that? Let's flip it over to the back. So again, it's already set to 0. Zero's on one side, numbers and everything else are on the other. When factoring, what do you notice that it's out in front? We have a negative, so when we have a negative quadratic. We're taking out GCF. What does our GCF have to be? It has to be a negative. Yeah, we can't have a negative number out in front when we factor. So the only thing we can take out is a negative 1. So when we do that, what happens to all of our signs? They split. So the negatives turn positive, and the positives turn negative. Okay, we'll put that equal just because we're factoring. So we have 3 terms. So we're going to try to split the middle. So there's a 1 out in front. Multiply first and last. What's 1 times 6? 6. Okay. And what are all the factors of 6? 6 and 2 and 3. That's it. Well, do any of those combine to give us our middle number, negative 4? No. Huh. So this is indicating to me that this isn't factorable, which means you're not going to have normal roots like we did on these. We could factor, we got normal numbers, we can easily graph it. So when this happens, what I'm going to do, I'm going to turn to my calculator. So go ahead, have your calculators out, and go ahead and graph this and y equals in your calculator just to see what's going on. Why is this a little different than the others? So go ahead, go to y equals, plug in negative x squared plus 4x minus 6. And then graph it. You might be noticing something about that graph. And some of your graphs might be a little off because we've been kind of playing around with the windows. So when you graph it, when you type it into y equals, go ahead and hit zoom, right here, in the middle, and then 6. And that resets your window. So, you change your window to do your quiz or practice or something, hit zoom 6, and that resets your window. So what do I notice about this graph? Yeah, it doesn't even touch the x-axis. So we're going to have x-intercepts? No. Okay. But we can still answer this because we want to know where part of this graph, I'm going to erase these stuff right here so you can see it. And again, go ahead and graph it. So it looks something like this. Rough sketch. That's the graph we got. Okay? But if we look back at our inequality, is that graph, where are we looking? Above or below the x-axis? Yeah, below, because it's less than. And what do you notice about the graph? The whole thing is below the x-axis. That means any single x value we plug in, we take 100, if we take 1,000, if we take 2, if we take negative 5, whatever x value we plug in, we're going to get an answer that is less than 0, or that is below the x-axis, that is negative. Okay? So when this happens, when it works for every single x value, we would say, any x value we plug in will work. Anyone. We're going to get an answer that's less than 0. Remember, that's what they're asking with these inequalities. We're trying to find which x values can we plug in that will satisfy it. And in this case, every single x value will work. So when we do this on a number line, well, if every single x value would work, what do you think we need to do? Here, only these x values work, so we only shaded that part of the number line. They don't think. Every single x value will work. They don't think. How would we write this as interval notation if every single value works? I guess all the numbers would be a better word to use here, I guess. I'm not really. about that. So if we look at f, it's the same graph. So something like this. We'll sketch. But this time, where are we looking? Above or below? Above, yeah. This is greater than 0, so we're looking above. But is any part of that graph above the x-axis? No. So is any x value we plug in going to give us a positive answer? No. So are any numbers going to work? No. We have no solution. So are we going to change anything on our number line? No. And then interval notation is 0. Nothing will work. Questions over that? A little different. Sometimes that happens. So look at G. Again, we need to first make sure it's set to 0. Check. Already done that for us. So now we need a factor. And really similar to the last one, what do we need to take out here? Negative 1. We have a negative out in front, so we gotta make sure we take out that negative 1. And again, when we take out a negative 1, what happens to those signs? We switch. So the negatives turn positive and the positives turn negative. So we can go ahead and factor by grouping. Pull one out front. Not grouping. Pull the middle. We'll eventually group those. So 1 times 12 is 12. And what are all the numbers that multiply to give us 12? 12, 2, and 6. Which of those will combine to give us 8? Our middle number. 6 and 2, but what do we know about those signs if we want a negative 8? Negative 2 and negative 6. So when we rewrite our middle, we now have 4 terms. We use grouping. Move the first 2 together, and the last 2 together. Another negative 1. What can we take out between x squared and 2x? And what can we take out? Oh, sorry. What are our leftovers going to be? X minus 2. And then drop down the negative, and between 6x and 12, what can we take out? 6. And what are our leftovers? Half. Yep, it's supposed to be a plus x. There we go. Make sure that's a plus. Yeah, this would be x minus 2. So when we write it in parentheses, and that negative 1 out in front, what's going to go in the first parenthesis? X minus 6. What's going to go in the other parenthesis? And then solve, so we get that x is equal to, and then x is equal to. We don't care about the negative 1. There's no x with it, so there's no need to solve for anything there. So then plot your zeros. You're going to plot 6 and 2. Which way is this graph opening? Down. Why is it opening down? No, there is a negative out in front. Go ahead and connect. Making sure your graph is opening down because there is a negative. Yeah, it's super important to pay attention. Positive opens up, negative opens down. And we're looking at the part of the graph where it is bigger than 0. So is that above our x-axis or below? Above. So what do you notice about that part of the graph? Is it connected or separate? Connected. So are our inequalities going to be connected. We have lines underneath. There's going to be lines underneath in our inequality. And then what's going to go first? What number? And what number is going to go second? Now we're going to go ahead and graph. So what kind of dots are we putting up 2 and 6? Closed. Lines underneath, so we want nice closed dots. And are we going to connect them or arrows in opposite directions? Connect. And then how would we write this in interval notation? So 2 to 6. And then we have closed dots. We put brackets around them. Start at 2, end at 6, brackets because they're closed dots. One more. So now it's about H. So are inequalities set to 0? No. There's that 8 on the other side, right? So what do we think we have to do with that 8? Subtract it. Move it over. And I'm getting 3x squared minus 5x minus 8 is greater than 0. So again, when we factor, multiply your first and last. To get what? What's 3 times negative 8? Negative 24. And what are all of our factors of 24? 24, 2 and 3 and 4 and 6. Which of those are going to combine to give us our middle number, negative 5? How do they have to combine though? We want a negative 5. Positive 3 and 8. Nope. So I'll go ahead. Read out your middle. 3, 8. And group. What are we going to take out between 3x squared and 3x? 3x. And what are our leftovers going to be? Good. What are we taking out between negative 8x and, or sorry, drop down the negative. What are we taking out between 8x and 8? 8. And then what are our leftovers have to be? You might be thinking, well, that was a negative 8. Well, the sign's changed because there's a, you technically took out a negative there. What's going to go in that first parenthesis? 3x minus 8. What's going to go in that second parenthesis? X plus 1. And then you solve. So then, that's unequal to 0. When we solve, what do we end up getting? Negative 1, and x is equal to? You get 8 over 3? Yes. You solve, you add 8, and then divide by 3 to get 8 over 3. So we plot these two graphs. We're going to plot negative 1. Here's the thing, it might be hard to tell what 8 over 3 is or where it is on a graph or a number line. So just divide. Just to see what it is. When you do 8 divided by 3, it's about what? 2.6, repeating, right? So it's about 2.7, it's about 2 and 2/3. That's just to help you graph it. We want to keep it as 8 over 3 in our answer. So 2.7 is almost 3. Just kind of estimate. Oh, and why is it opening up? There's no negative out in front. So are we looking above or below the x-axis? above because it is greater than 0. So again, if we look above, we're looking at this section right here. Is that connected or separated? So are inequalities also going to be separated? What's going to go first? -1. What's going to go second? Keep adding that fraction. So it's less than -1 and then bigger than 8/3. It's always less than your little number and bigger than your big number. So what kind of dots are we putting on our number line when we graph it? And then 8/3 again, just estimate that's between 2 and 3. Are we going to connect these dots or arrows in opposite directions? They're going to be separated because everything else is separated. And then who can tell me how we write this in arrow notation? Megan? Where are we starting at negative? I'm sorry, negative. Good. Good. And we're putting around both? What? Perfect. Good. Perfect. Make sure I know the fraction. Keep it a fraction throughout your answer. You can just see what it is as a decimal to help you decide where you're plotting it. You keep it as a fraction throughout your answer. Okay? Questions over that?